Okay, so this is going to be your video for your Algebra 2 1 through 55 review test. Now, I'm going to apologize if you're in a geometry class with the 1 through 55 review, because evidently my audio sounds terrible. I finally did figure it out, so hopefully this sounds a lot better than that review, but that you are able to follow at least some of the work and catch some of the audio in that. But with this, hopefully this goes out a lot better. Question number 1 that we see here, we're going to solve, we should have 30 questions on this review. This first question comes from lesson 35, solving quadratic equations. 1, we want to find the zeros in this, which means that our very first step is to factor this down and then set those different factored forms equal to 0 and solve. So we're going to write this up. We're going to factor this. Because it's x squared, we're going to get x and x. Because it's plus minus, the only way to get that negative there in front of the 80 is to multiply a negative and a positive together. So I'm going to get a positive and negative. What I'm going to notice about that positive in front of the 11 is that whatever I'm whatever I'm adding up there is that my positive has to be greater than negative in order to get a positive number. So I'm going to look at numbers that multiply to be 80. But whenever I add them up, they have a difference of 11. So, you could take 80 divided by 2, that's 40, that has a much bigger difference. We could take 80 divided by 4, that's going to be 20. Well, there's a difference of like 16. Let's take 80 divided by 5, that's 5 and 16. That has a difference of 11. So what we're going to get here is positive 16, negative 5. And so we're going to take x plus 16 equals 0, subtract the 16, so x equals negative 16. We can do the same thing with x minus 5 equals 0, add 5, I'm going to get x equals 5. So my two answers are negative 16 and 5 for number 1, x equals 5 or x equals negative 16. Either one is an option. If I plug in either number for x, it's going to equal 0. All right, number 2, write an equation in slope-intercept form for the line perpendicular to y equals 5x plus 4 that passes through the point negative 8, 4. Because we want perpendicular, I'm going to look at this slope, and I want the opposite reciprocal of it. Opposite of that is negative reciprocal of 5. 5 is 5 over 1, so reciprocal is 1/5. So I want a slope of negative 1/5. We're going to use negative 8, 4, and we're going to use our equation y minus y1 equals m times x minus x1. So as I plug that in, I'm going to go y minus 4 equals negative 1/5 times x minus, x minus negative 8, which, as we know, should be a plus, right? Whenever I've got a double negative there, that becomes addition. Carrying this through, I have y minus 4 equals negative 1/5 x, negative 1/5 times 8, negative 1 divided by 5 times 8. My calculator comes out to negative 8/5. Okay, so I get negative 8/5, leave that as a fraction. I'm going to add 4 to it, but I want a common denominator. So my common denominator is going to be 5. So because that 4 is 4 over 1, I need to end up multiplying it by 5 over 5, which is going to leave me with 20. Okay, so I'm going to get y equals negative 1/5 x. Negative 8 plus 20 is positive 12, 12/5. This should be my answer. Let's check our answer key. Number 2, y equals negative 1/5 x plus 12/5. All right, let's move on to number 3. If this will, let me scroll up here a little bit. Right there, just about. I'm going to end up bringing my work kind of down here. With this, on question number 3, we're looking at lesson 37, adding and subtracting rational expressions. What I want to do is I want to factor the numerator and the denominator of both my fractions. So I'm going to look at what I can take out of 2x squared minus 32. I should be able to take out a 2, leaving me with x squared minus 16. Okay, and I can reduce that even further. X squared minus 16 is a sum difference because I notice that I've got an x and an x, but negative 16, notice that there's no x value in here, but it's a perfect square, so I get positive 4 and negative 4. All right, so that's going to be there. I can come down to my x squared minus 4. That's a sum difference because I have an x squared and minus a perfect square. So I got x minus x plus. That would be minus 2 plus 2. Because what's going to end up happening here is that those 4s, I'm going to get, as I FOIL that, x times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. That negative 4x and that positive 4x are going to cancel out. So I'm going to be left with x squared minus 16 as I multiply the 4 times negative 4. The same thing ends up happening down in the denominator. X times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. Those are going to cancel out. And negative 2 times 2 is going to be that negative 4. Negative 2 times 2. All right, so I've got this as I simplify. X plus 8 won't change anything there. And then I've got x plus 2. Now, I can't change anything in that second equation or that second fraction, but I'm going to look, I'm going to see that I have an x plus 2 here. So in order to add or subtract fractions, I need a common denominator. And so the common denominator to this is actually taking this and multiplying it by x minus 2, but I need an equivalent fraction, so I'm going to multiply by x minus 2 over x minus 2. Okay? All right. Let's see. Let's look and see what that does for me in the end. I'm going to scroll down. Well, we might do. Let's carry this down. I'm going to erase a little bit here. And I'm going to work my way kind of back up because I've got it all down here, but because of where my room is, I'm going to take my second equation up to the top. So let's see. Right here, we can FOIL that back out so that I've got x squared. Let's see, x squared. Okay, minus 2x plus 8x minus 16. Okay, we know that negative 2x and 8x are going to be 6x, positive 6x. Okay, we know that we've got a common denominator of x plus 2, x minus 2. So I can come back and I can bring this original equation back up. So I can actually end up taking this all back in so that I've got 2x squared minus 32. There was nothing to end up changing there. So now what I can do is I can take the numerator, combine those like terms. Okay, so I've got 2x squared minus x squared. That's going to leave me with a positive, let's do a different color here, x squared, right? Because between this and this, that's going to be x squared. I have a positive 6x right here, and I've got negative 32 minus 16. Negative 32 minus 16. Negative 32, subtract 16, I get negative 48. Negative 48 over x plus 2. Ooh, hold on a second. We forgot something. We forgot something that would commonly be forgotten. Because this negative right here, that negative needs to be distributed to everything. Okay, so we're going to erase this. Okay, I know that frustrates you guys. But this is actually a negative, and this is actually a positive. Okay, so we still wind up with x squared, but it's negative 6x, and it's negative 32 plus 16, which is going to be negative 16. Okay? Now, keeping in mind our denominator is still x plus 2, x minus 2. Let's see if our top, as we factor that down, becomes anything easier to work with. We've got x, we've got x. Let's see. We got negative, negative, which means we're going to have a positive negative, but my negative number has got to be greater. Things that multiply to be 16, but have a difference of 6. Okay? Well, you can take 16 and divide by 2, and you're going to get 8. So if we have a negative 8 and a positive 2, and we have that all over x plus 2 and x minus 2, what we should notice is that my x plus 2's are going to cancel out. And for question number 3, we wind up with a final answer of x minus 8 over x minus 2. So I apologize for how crazy that looks, but sometimes when making these videos, you have limited space. I mean, the only other thing that we could really do is just kind of go over to a full blank page and try to draw this out and stretch it down. So hopefully you were able to follow at least some of that. You can always slow it down and go back. I apologize for needing to erase in some places there. All right, let's clear that. Question number 4 says, use long division. And I know you guys really love long division. Question number 4, this comes from lesson 38, dividing polynomials using long division. All right, so let's start off by making an actual division bar. We got 12x to the 4th minus 18x cubed plus 36x squared. But I've noticed, well, we won't worry about factoring anything out. Let's just do this as is by 6x cubed. So we're looking at what would it take to get 6 to be 12? Well, we'd have to multiply it by 2. 6 will go into 12 evenly 2 times. And x cubed will go into x to the 4th if I multiply it by x. So that's going to give me 12x to the 4th. If I subtract those like I normally would, they're going to cancel out. I'm going to bring down negative 18x cubed. Right? In order to get 6x cubed into negative 18x cubed, I'd have to multiply by negative 3. It's already x cubed, so I wind up with negative 18 x cubed, subtract, because that's ultimately positive, and you know that these are going to cancel out, and that's going to be 0. And then I've got to bring down this 36x squared. And this is where things get a little tricky, because we'd have to multiply 36 by 6 to get 6 to be 36. But how do I get x cubed into x squared? Well, I'd have to put it with x in the denominator of that, because technically speaking, I would have to multiply it by 6x to the negative 1. Well, if I move this down here, okay, that becomes a positive, right? That equals 6 over x. So my answer is 2x minus 3 plus 6 over x. Okay, and that comes from lesson 38. Okay, that's question number 4. Okay, number 5. Number 5 over here, write an inequality to represent the graph. The first thing we want to do is we're hoping to put this into slope-intercept form. So y equals mx plus b. And in this, we always look for the y-intercept first. We see that that's negative 5. So I can put negative 5 there. The next thing I want is the slope. All right, so I'm looking at the next place where it seems to cross a coordinate position, which looks like right here. So it looks like it's up 2 over 1. Let's see if that works again. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right, because it's rise over run, up 2 over 1 has a slope of 2x. So, but because it's an inequality, I'm going to look at some other things here. Notice that this is a dotted line. Okay, which means in my inequality that it won't have an equal to bar underneath of it. So y is either less than or greater than. Okay, so we've got our y here, and we have to determine is y less than or greater than. And so we want a statement that is true. Now we could use 0, 0 for our test plot, but because 0, 0 isn't in the shaded region, we would be looking for an answer that's false, and that can be kind of confusing. So what I like to do is let's use an answer that's true. All right, let's use coordinates that are in the shaded region. And we could come down here into our negative area, but in my experience, people kind of struggle with using negatives anyway. So let's use positive coordinates that show up in quadrant 1. Let's use something like this right here. And that coordinate is 4, 1, which means I'm going to plug in 1 for y, 1, and I'm going to plug in 4 for x. 2 times 4 minus 5. So I got 1, and 2 times 4 is 8, 8 minus 5, and I got 1, and over here I have 3. Okay, well, our question is 1 less than or greater than 3? Obviously, 1 is less than. So what I want to do is I'm going to use that same symbol there that's going to be correct. So y is less than 2x minus 5. Now, I can use my graphing calculator to check this. I know we haven't gone over this in class, but I do want you to see it now. If you'll pay close attention, I'll show you how we can double check our work. Again, double check our work, not answer our work or just say, hey, I did it in a calculator. So here's my 2x minus 5. And if I want to see for sure that it's less than, okay, I'm going to keep hitting, well, I'm going to go over all the way to the right. And I'm going to wait till I see that shaded portion on the bottom. That's going to be my less than. And then I'm going to graph it. Okay, and I should see something that looks a lot like, hopefully, let's see, let's make it fit. Zoom, fit. Maybe we're just not. Okay, we got y equals 2x minus 5. And we're not showing anything. Try one more time. Doesn't even look like it's trying. So I'm going to try turning it off and on again. Let's clear some things out. Still nothing, which is embarrassing. It's not like okay. Okay, it should be 2x minus 5 graph. There we go. I'm not sure exactly what was wrong, but we should notice that yes, that does look relatively, and we could count our tick marks and see, but that's what we should get. Now, our graphing calculator won't do the dotted solid line, at least this graphing calculator won't, but we should get enough of our information. Okay? All right, so that's question number 5. That's in our equation there. Okay, let's come down to question number 6. All right, so we've got a number over some radicals. Okay, number 6, we are at lesson 40, simplifying radical expressions. Okay, this requires me to multiply by the conjugate. Okay, multiply by the conjugate. Let's make sure we're using the same numbers in the same position. Multiplying by the conjugate means that I'm going to multiply by the denominator, but with the opposite operation. So radical 6 plus radical 5. Onto the top, so keep doing that, and the bottom. Okay, so then we're going to distribute across the top. So that's going to be 5 radical 6 plus 5 radical 5. Okay, and across the bottom. Sorry. All right, and you'll notice that it's a sum difference, and by that I mean that that everything's in the same position except the operations are different, which means my middle two terms are going to cancel out. So radical 6 times radical 6 is going to be 6, and radical 5 times radical 5 would be 5, but I've got the negative right there, so it's going to be minus 5. Okay, so this one does have a trick. Well, actually, because this is just 1, right? I just need 5 radical 6 plus 5 radical 5, and my answer is complete. That's question number 6, which is lesson 40. Okay. Number 7. Harry and Selma start driving from the same location. Harry drives 35 miles north. Selma drives 84 miles east. How far apart are they when they stop? This is using the Pythagorean theorem and the distance formula. So let's imagine that we have an intersection here. Harry's driving 35 miles north, okay, and he stops. Okay, Selma is coming from this same spot, and she's going to the east, 84 miles, and he stops. The question is not if they came back to that same spot, how far away. The question is asking how far away are they as the crow flies? How far is their actual distance? So that's just the Pythagorean theorem, which is a squared plus b squared equals c squared. 35 squared plus 84 squared equals c squared. Because this is a right angle and my green line is my hypotenuse because it's opposite the right angle, we can grab our graphing calculators again. Again, you're going to show me this. You're going to write down this work. But I can actually do this as all one thing. So I can do this as 35 squared, the square root of 35 squared plus 84 squared. Okay, and that should give me my final answer of 91 miles. 91 miles is my answer here. That's how far apart they are. Okay, and that's how we want to use the Pythagorean theorem. I'm showing you how to use your calculator, not necessarily that you can just do that on your test, because if I'm taking the test, I want to make sure that the teacher knows that I know what I'm doing. Number 8 comes back to what we've really just done with the previous question, except with having a 5 on top. Now we've got radical, we've got a 6. So I'm going to do this relatively quickly. 6, I got radical 6 minus radical 5. So we're going to multiply by radical 6 plus radical 5 over radical plus radical 5. Okay, that's going to give me 6 radical 6 plus 6 radical 5 on the top. There, I'm going to get 6 minus 5, which is 1. So my answer is 6 radical 6 plus 6 radical 5. Because it's over 1, I don't need that. I can just get rid of the denominator altogether. So my answer is 6 radical 6 plus 6 radical 5. Again, that's lesson 44. Rationalizing denominators. All right. Hoping to get at least a couple more questions done on this video. All right, we've got a scatter plot here. Hopefully I can get all that information in here. Scatter plot shows the relationship between the weekly sales total and the number of different rug designs a store has. Based upon this relationship, predict what the total sales will be when the store has 10 different rug designs. So if we're looking at number of rug designs, that was kind of a crazy question. Let's see. What was this, number 9? Let's see. Well, when the store has 110 different rug designs. So we want to look at our scale so we know what our numbers are. This would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is where I'm looking at right here. And you notice that it's pretty linear. So I should be somewhere between this point and this point on this line. So it would kind of make sense to be about right there because most of our data is kind of in a line. So this is where we look across and notice that this is going 5,000, 10,000, 15, 20, 25, 30, 35. So I can reasonably say $35,000. Okay? $35,000, and that's our answer. That's lesson 45, finding the line of best fit. Wouldn't be a bad idea to go back and look at notes from that lesson. Okay? All right, lesson number 10. The camera is mounted at a point 4,800 feet from the base of a rocket launching pad. Assuming the rocket goes straight up, what's the height of the rocket from its launching pad when the camera angle is at 30 degrees? Round your answers to the nearest foot. Question number 10. comes from lesson 46, finding trigonomic functions and their reciprocals. Now, because this is a 30-degree angle, and assuming that that rocket's going straight up, there's a couple different ways to find this with information that you've just been given recently. So let's refer to, let's see, we'll make our rocket. Okay, there's my rocket, not too bad if I say so myself. Okay. There's my camera. Okay, there's my right angle. Okay, and our camera is mounted at a point 4,800 feet away. And once this gets to a 30-degree angle, our question is, how high is the rocket, okay, from our launch pad being right there. So if we're wanting to use trigonomic functions, we can certainly do that. We could also use 30, 60, 90 trig functions where we're seeing that this is a 60-degree angle. Okay, but in our trig functions, right, what we see here is that x is opposite my angle and 4,800 is adjacent to my angle. So I've got opposite and adjacent. The trig function I want to use here is tangent. So tangent my angle, tangent 30, equals opposite, which is x, over 4,800. So I want to multiply by 4,800 on both sides so that I'm solving for x. So in my calculator, I'm putting in 4,800 tan 30. Now, the first thing to check, anytime you're doing a question like this, is check your mode. Make sure it's in degrees. All right, so I've got 4,800 tan 30. Okay, and that's coming out to 2,771, and I want it to the nearest foot, so it's 2,771 feet. Now, like I said, that's not the only way to solve this question. If you remember some of your 30, 60, 90, I'm trying to remember if you guys have gotten this far yet, but my 60 is 4,800, which would mean that, you know, it is 4,800 equals x, let's see, x radical 3. So I could divide 4,800 by radical 3. And if I try that, 4,800 divided by the square root of 3. Let's see if I get the same number. I get the exact same number. So there is more than one way to get to your answer there. Okay, and for now, that's going to be where we're going to stop. And in the next video, I'll pick it up with question number 11. Question number 10, again, just so I've said this, comes from lesson 46, finding trigonomic functions and their reciprocals. All right.